Yes. Yesterday, first of all, good evening, all of you once again, and welcome in this session. Today, we will cover the content on 2D and 3D plotting, which is highly required for visualization of our information, of our findings, whenever you have a very large data. Okay. And as soon as when you will import, first you need what this data is for purpose, what information this will visualize. So if the data is available in your Excel file, you can easily import and visualize. Before that, first we will target uh, when we solve any kind of differential equation or any type of mathematical model, and if you have any kind of a function which you need to analyze, okay, you want to study the behavior of the function. So we need its graphical interpretation of our findings, of our results, and the MATLAB provide interface, and there is very small coding to visualize the result, whether it is in the form of Excel or whether you have your own findings, like someone are a research scholar and they want to use MATLAB for their work. Some are very beginners and want to learn why we need. And I saw there are so many students. Uh, their UID I think start from 23 MMA 122. There are UID of the institute. There are many research scholars. There are some faculty members. Okay. So while we are studying mathematics, and visualization play a very important role to understand our findings, as well as to understand the behavior of function. Okay, when you solve any kind of differential equation, whether it is ODE, PDE, partial differential equation, whether it is a system of differential equations, in each case, we get some the findings or the result, and all these results are functions only. Okay, and to understand the solutions or their behavior, okay, we need to visualize them. So for the visualization, sometimes we have a function of one variable, and sometimes we have the function of multiple variable. Sometimes we have a function of a complex variable. So in each case, we can easily visualize. So the most important thing is to understand the syntax and how we can give the statement input. And in this session, I will try to explore everything hands-on. Some will be there theoretical part also, but most of the things we will do all these things by using MATLAB. And one more thing I will let you know before starting the session. Sometimes we don't have information how we can plot. MATLAB itself help you to get the information how you can uh, use your statement or the syntax for plotting 2D, for plotting 3D, okay, and for multiple graph. And along with in the modern era, there are so many ways to learn. Okay, so the purpose of this activity is not just to present the prepare content and deliver all these things, but to make you so I you can say self learner. Okay, I will present here some more examples so that how you can get all this extract by using AI tools also. Sometimes we need help and how we can write the code. We don't know about how we can proceed. And I will also present some examples with the help of ChatGPT, Birds is there, along with how MATLAB itself will help you. Okay, so all these things will help you more and more for your career, for your research work, for plotting the results which you have and what you want to do with MATLAB. Everything. Okay. And the today's session, which we are going to discuss, I am sure will help you in the coming sessions. One more thing, yesterday I started the recording in the beginning, but during the lecture, I press a key by using the same, the recording stopped. So the recording is not available in the system where you have the account. So what I will do today after this session, I will record the entire lecture which I delivered yesterday and upload in the system. And along with there are some participants who are not directly registered in the platform. I will provide the link by using the same. You can get all the informations which are some are missing in the yesterday. Okay, so don't worry. And whenever if you have any kind of problem, you need just to put your query in the WhatsApp group, and I'm sure I will frequently reply you regarding your query. Okay, if there are a problem related to the presented content. So now, first I would like to share the screen. Yes. So this is my desktop. First, you need to come at this place. This is MATLAB command window. Okay. And yes, CLC. So first I have some queries related to the content which we presented yesterday, so that I can check whether you are understanding or following. Please let me know what is the purpose of the command window. Anyone can expand command window, current folder, command history, and then we have the workspace. These are the several four partitions which are very important while to start work on MATLAB. Anyone who can expand? Yes, please. Anyone? You can open your mic and please start. What do you mean by command window, command history, current directory, and workspace? So when you will start to work on MATLAB, these four partitions play very important role to control the entire MATLAB. Anyone? Ibrahim, please open your mic.
Thank you. Good afternoon, sir. Good evening.
Good evening. How are you?
No, it's afternoon in Nigeria, so
Yeah.
yes. The
So please
workspace.
explain about the yesterday's content and I explained these four components of the MATLAB which are very required to start to work on MATLAB. Please explain
The
these
first,
four components. Yeah, please.
the current folder is where you
Yeah.
have all the documents you are currently working on. The command window is where the real activity is taking place, or what you need to key in and get that. Then the workspace displays the variables and the values that you have on the command window. Then the command history is a storehouse for all the information that you have either on the command window or on the workspace. But in addition to the information you have, if you clear all the information under on the command window or the workspace, the command history still have the data. So you can always go there, click on it, then you have it back on the command window. Thank you.
Great. So I hope these four components are very clear to all of you. Now, I am going to share my screen, and this is my desktop. Yes. So yesterday when I was sharing about, we were discussing about elementary functions which are inbuilt in MATLAB and how you can extract the information about these elementary functions. Okay, so little bit we will discuss about the yesterday's content, and then after we will start for today's session. Okay, so what you will do, help, then ELFUN. This will provide us the elementary functions, and when you will enter. Okay, this is just for you the information how the functions which are inbuilt in function, and what are the syntax and how you can use. Okay, just I will present here one example. Okay, so here at the top, at this place you can see this is the entire elementary function list which are available in MATLAB itself. Okay, when you will press on sign function, so this will return about the information of a sign function. Okay, so here is sign of argument in radian, and sin x is the sign of the element of x. Okay, and a sign, sin d, and sin pi. There are also some more examples. So a sign will return us when you will click at this place, a sign. Okay, so a sign is inverse sign result in radian, and a sin x is also arc sine of the element of x, and complex result are obtained if absolute value of x is greater than 1.0 for some element. Okay, sometime if you have the complex element, in that case the absolute value must be greater than 1.0. Okay, now if there is also uh, you can see sin d. When you will click on sin d, uh, it is saying that sign of the argument in degree. When you are using sin d, the argument will be in degree, or the for integer of n, sin d n product 180 is exactly 0. The value of this part will be 0, whereas sin n pi reflects the accuracy of the floating point value of pi. Okay, you can use these two functions in two different ways. As yesterday we were trying sin, if you will put here pi, then the value is this one. Okay, if you are using sin d, then pi. This value. And if you have sin d 90 and enter, it is 1. If you are using like in this way, sin 90, so this will not be equal to 1. So here the argument is in radian, and when you are using sin d, then it will be in degree. Okay, and also a sin 1. Okay, or you can use a sin d 1. So when you are using this one, this is returning in corresponding to the radian, but here the argument is corresponding to degree. Okay, so that's why here is 90, and at this place we have 1.5 1.5708. So the thing is, I will not explain all this. You must do all these examples yourself. Okay, but I present here one example how you can use and how you can get the information about all these functions, because when you have a lot of experiment, a lot of findings, depends upon which type of work you are doing. So from this place, you can easily extract all the corresponding examples. List is there, but just you need to understand the syntax. And these syntax, just not read, do some experiment on it for better understanding. As you can see the absolute value, when you will press here, yes. So here you can get some example and how you can uh, use. If you want to enter the complex number, how you can enter the complex number, z is equal to, yes, I is iota, okay, and j is also iota. Okay, so there are two symbols for complex number in MATLAB, whether you are using iota or j. Okay, now if you want to enter any complex number, like z is equal to, you have 2 plus 3, then I. See what happened? Yes. So this is complex number. And if you want to get the absolute value of the same, absolute value of z, okay, this will return the absolute value. So just do experiment, use them. This is the required absolute value. So there are all type of functions which you need for your work. First, before using, you need to experiment, you need to check how you will use. Just you need to extract the syntax and for the use. Okay, and then this will help you. All type of functions. Then you have some more functions like logarithm function. Okay, when you will click, then you will have the example. This is the syntax. Okay, this is the syntax. And for the same, if you have log base 2, press it, and this is the syntax to use. Okay, in the very first line, this will expand, and in the second line, this will give you the syntax to use anywhere. Okay, so you can use this syntax for some computing part. If you have the value at place 4 and enter, then also from the keyboard, there are 4 arrow signs. One is upward arrow sign, left arrow sign, downward arrow sign, and right arrow sign. When you will press upward arrow sign, this will return all the commands which are used in the command window. You can see. And when you will press downward, then it will return the latest value. When you will press the right arrow, your cursor will move along the statement on the left side. And by using right arrow sign, the cursor will move on the right hand side on the statement. Okay, so this is also sometime useful to extract the used statement in the command window. Okay, so here you can use 10, and this will return the corresponding value of log 10 with base 2. So here, so many examples, just you need to use. Okay. And if you want to check more example, so here all type of trigonometric functions you can see here, inverse sine, hyperbolic functions are there. Press this one. So here is the cos hyperbolic function, and this is the syntax which you can use for any value of x. Okay, just you need to enter cos h, and at its place you need to put the value. Okay, and this will return the corresponding answer. And also sometimes if you have array like x is equal to you have 0, then we have 0.01, then colon 2. So I have this array and I want to compute the values corresponding to this array for hyperbolic function. I have y is equal to cos hyperbolic function, and at this place you will pass this array which is x equal to, and when you will press it, this will return the corresponding values of a cosine hyperbolic function, okay, or hyperbolic function of cosine. So these are the values for this function. We pass x array, and these are the corresponding values of the same function. So in this way, these are the simple examples. By using, you can do various type of experiment, and all these will help you. And one more important thing is I explained yesterday, all the inputs in the form of statement which we give this MATLAB will always convert in the form of matrix. And on the basis of this matrix, this laboratory perform various operations according to our instructions. So you when you will visit on the workspace, see here, we have the latest y. This is y. This is x and this is y. Okay. When you will double click on it, these are the values, one dimension. Okay. Yes, maximum is 201. So these are the values in the form of matrix. Excel itself is a matrix. Okay. So the values which you will observe at this place are in the form of matrix. And on these arrays or the matrix, this laboratory perform according to our instructions, what we give them. And similarly, we have this is X array and this is Y array. One more important thing, when you will import any Excel file in MATLAB, and you can easily import by pressing at this place. You can see import data. When you will click on it, right now I don't have any Excel file. Okay, you can choose the Excel file. I check whether I have any Excel file. Yes. Just 1 minute. Yeah, you can see the Excel file has been imported. Okay. So when this Excel file will be imported, and you will click here. And you can see that in the workspace at this place, this Excel file is loaded here. Yes, but I do cancel. Uh, when you have any type of array, then you can plot them. See here, what you will do after importing any file, which is in the form of Excel, and this is very simple visualization. Just you need to click, and by using just click, you have the visualization of the data. I just select this file. I have X array. Okay, I have Y array. I have this data also, but in this data, there is no numerical value. That's why I'm not selecting this one. And yeah, I will try later adding data which is in the form of numerical. So just click this one. and then go to plot. So when you have the data in the form of Excel, and there are several arrays, but in this we have only one array. Then at the top you can see this is the first icon for home. Then we have the plot, and here you can see several type of functions are there to visualize the information which is available in our Excel file. Just you need to click at this place, and you can see this is an graph for the X array. The X array is in this form. If you will click Y, okay, because X is just we have an array, and the difference between each consecutive number is equal, same difference. But Y is not the same, and just you need to click on Y. Y array has been selected, and then go to at this place. You can see the visualization of these values. Okay, so this is the behavior of the function. Just you need to click and you can have the visualization, or you have the graph of the data which you import. Then you can click at this place. You have this graph. You can visualize in the form of a bar. You can have a pie. Okay. Then we have histogram. This is the histogram. Then you have the semilog. This is the semilog graph. Semilogy, log. Okay. Then comet. By using the comet, you can visualize in the animated form. You can see this graph is animated. Again, this is comet. You can see. Then we have stem. This is the stem graph. Stairs. And you can maximize from this place. And when you will click at this place, you can see there are various type of functions are there. The thing is that all these functions which you observe at this place are used for different type of use or task. As you can see here, first one we have the MATLAB line plot. All these are line plots. Then we have the stem and stair plots are there. This is the stair plot. Okay. And first one is the stem. Then we have the MATLAB bar plots, and all these this type of plots are used for statistical analysis. Okay. Then you can see here some more plots are there. MATLAB histogram, then MATLAB polar plots. You can compass the graph. You can see. So all the elements are in this direction. And there is a polar histogram is also there. This is polar histogram. Okay. And polar plot is also there. This is polar plot. So before using these functions, you must be very familiar which visualization is required for your work. Okay. And behind all this, the geometry concept is very important, because geometry play a very important role to understand the visualization, to study the graph. So it depends upon your basic understanding about the visualization and the understanding of the geometry and its concept. When you have the visualized result, this will be very helpful to understand all these. Okay. Then, yes, at this place you can see a MATLAB analytic plot. Then you can see the signal processing toolbox. So when you will because when you will import the data, and there are various type of toolbox are there, but it depends upon which type of visualization is required and which type of task you are doing, which in which area you are working. Okay, so here this type of, you can see here the signal processing toolbox. Okay, and then you have the signal processing toolbox spectral estimation. If you need, then you can take help from these icons. Okay, if I will select on this one, this will return the corresponding graph. But this will be understandable only if someone is working on the image processing. On otherwise, these all these things are useless. Okay, so I will not go through about the more detail about what is image processing, signal processing, etc. Just I want to let you know the use of plot and from where you can extract all these informations. Okay, so everything is available in MATLAB 2022, whether you are using the version MATLAB 2015 onwards. So all type of help, all these type of apps and icons interface are a little bit similar. There is no big difference. Okay, someone raise hand. Good evening. Uh,
Yes, I did.
yes, yes, please.
Yes, thank you very much, Prof. I want to ask a question.
Yes,
On
please.
these plot types, I realize that some are asterisk. Some of them have asterisk on them. They have star on them.
I don't get your exact question. Please repeat, or please text me.
If you scroll up, if you take the plot up, you see some of them are asterisk. Okay, let me send message.
Can you please text me?
Yes, I'll do that.
Yeah. If anyone have more question, you can unmute your mic or you can put your question in the chat box also. I will check and I will try to reply corresponding to your query. Okay, also there are some more interesting graphs you can see for statistical and machine learning, like a box plot. Okay, box plot. This is the maximum value. This is the minimum value. Then this is the you can find here maximum value, minimum value. Then mean, median, and mode. First quartile, second quartile, third quartile. But first, before plotting all this, you need to understand about uh, this box plot. Okay. So here is only one array. That's why we have one diagram. And if you want to know more about, you can get the information by searching. Just 1 minute, I'm showing. Yes, here, enter box plot. Okay, image. So from this image, you can, yeah, this is the image for box plot. Okay, and box plot play very important role when you are interested to work on data science or machine learning. So this is the minimum value, and on the right hand side we have the maximum value. This is the upper quartile, and this is the lower quartile. This is Q1 and this is Q3, and this is the median, and this is the interquartile range from this part to this part. Okay, and you can get some more information by using several from the different examples. Yes, lower quartile, upper quartile, this part and this part. Sometimes we have the data and we have the upper maximum and minimum value, but first quartile exists at this place and upper quartile lies at this place, and sometimes we have the outliers, the values which are different from the remaining data. Okay, there is some specific value which lies in the outlier. So those values will exist on the uh, left side of minimum and right side on the maximum. Okay, so when you are using these plots, first you need to understand the geometry of this type of plot, and then you can do several type of experiment according to your desire, according to your requirement. Okay, so okay, yes, I want to check the question. Thank you, sir. I realize that some of the plot type are asterisk. My question is that it is because we have used the earlier or the MATLAB in suggesting appropriate plots for the data. Yes, 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 this one. Okay. So this is just when you will select the arrays, and by using this app, MATLAB will suggest itself, okay, about this graph. And when you will select these two variable, okay, now we have two arrays. So according to these two arrays, MATLAB itself will suggest. So if you are selecting only one, see, we have these options are there. And as soon as you are selecting two arrays, change. Okay, now we have this. And from this place, you can find some more interesting icons and you can plot them. Here is the scatter graph. This is the scatter graph. On the horizontal line, we have the X value, and on the vertical line, we have the Y value. Okay, one is X array and other is Y array. Okay, and similarly, you can have the bar graph and you can use histogram. Then, if you want to plot in 3D, you can use this is 2D. Okay, so all these are based on the data which is we are importing, which is available in Excel file. Okay. Now I want to close all these simple examples. Now, just 1 minute. Yes. So the today's session was on is based on 2D and 3D visualization of functions and data in MATLAB. Mainly the content which we are going to cover, and some has been discussed just for the basic introduction, and all these things which we will discuss in the remaining entire lecture will be very simple as you saw here, but the plots which I present before starting the session are for only based on data. Okay, but here first we will discuss about 2D and 3D plotting of a mathematical function in MATLAB. Okay, this is very important. How we can plot mathematical functions in MATLAB. So here, brief overview of the importance of visualization mathematical function and introduction to MATLAB as a powerful tool for mathematical visualization. So some basic information why we need just 1 minute, please. Yes. So why the graphical interpretation is required for us? The importance of visualizing mathematical function lies in the ability to gain a deeper understanding of abstract concept and relationship. Visualization provide an intuitive and graphical representation of mathematical functions, making complex function and complex concept more accessible. This aids in understanding the behavior and characteristic of the functions. Visualization functions help identify patterns, trends, and relationship within the data. Graphical representation make it easier to recognize symmetry, periodicity, and the other important features that might be challenging to discern from new mathematical expressions. Visualization serve as a power tool for problem solving. By observing graphical representations, individuals can quickly identify critical point, zeros, extrema, and other properties that are vital for solving mathematical problems. And also, graphical representation are effective tools for communication in both education and professional settings. Teachers can use visualization to expand mathematical concept while researchers and professionals use them to convey findings and insights to a broader audience. And the last important thing is that mathematical functions often model real world phenomena. Visualization enable the examination of how change in parameter affect the behavior of these models, facilitating the understanding of real world system and their dynamic. As you can see that during the COVID, the various type of models has been established, and the COVID depends upon various type of parameters, and all the parameters were studied very critically, logically, and on the basis of visualization. Every person can understand the spread of this disease, how the disease is being controlled or can be controlled. Okay, so the visualization of any type of model, whether it is a mathematical model, whether it is a statistical model, whether it is related to for weather, for any kind of prediction, the visualization play a very important role to understand all these things. So that's why sometimes we are studying about differential equations, and we get the solutions of ODE and PDE equations, but we never check the behavior of the this type of equations, and after getting the solution. Okay, there are several dynamic model. Without visualization, we are not able to understand the behavior of the dynamic model, whether it is a ODE or in the form of a PDA. But if you are able to visualize the dynamic model, then this will help us to understand the existing model. Okay, and we can easily find the solution. Or sometimes if we have the findings, but what we get in our findings, without visualizing all these finding, we are not able to understand. So visualization play a very important role in all type of whether it is a data or whether it is a mathematical model, whether it is a dynamical model you are using in any branch of science and applied sciences. Okay. MATLAB basics for plotting. Here are some partitions. First, a quick recap of basic MATLAB syntax for mathematical functions, which we discussed just now, and use of the plot function for 2D plotting, and introduction to the EZ plot. Okay, let's we discuss all these. Yes. This is our MATLAB window, and okay. CLC, use CLC here. So the command window is clear. So first, the thing is that how you can take help from MATLAB itself. This is also I will explain along with our lecture, and how you can take help from ChatGPT for this type of task, how you can take help from BARTs. Okay, so first we are discussing from the MATLAB. On the right side, this is the search place, and you will enter here 2D and 3D plotting. 2D and 3D plotting. Okay. And enter. So as soon as you will enter, the new window will open. Okay. You can see here, this is the new window. If you have MATLAB in your system, you can check it. So on the top, what you can see here, this is the plot to the line plot. There are several type of plots, plot graph, nodes, edges. Then you can find the plot point, cloud view, constructing spline, curve, plot. Various type of examples are there. Okay. Now the most important thing is how you can get the syntax, because everywhere syntax play a very important role, and without understanding the syntax, we are not able to use MATLAB for our work. If you have any question, please don't hesitate. You can unmute your mic and put your question. I will be very happy if you put your questions. Sometimes I think that this is only one way lecture. I don't like one way lecture. If you will interact and you will put your questions, I will be very happy. Yes, please. Okay. So here you can find, at this place you will click plot. And when you will click, you can see these are various type of examples of a syntax. These are the syntax for 2D line plot. Okay. If you have a simple function, then you need plot x, y. Okay. If you have, then you have this example is also there. If you have multiple functions, you want to plot 2 or 3 functions, then you can use this one. Okay. If you want to get the example for this very first, just you need to click on it. And this will expand about these things. And after that, this will give us some example. Scroll down and here you can find the example. And you will be very happy to see here, this is the corresponding code. What is there? X is equal to, we have 0 to 2 pi. Okay. And the length of sub interval is pi upon 100. See here in the MATLAB. Yes. So what you will do, first you will choose X array, X input for the function, because if you have a function, you need to pass the value. Okay. The value is range which you want to assign for the function. See, we are choosing from this place 0 to, this is pi upon 100, then colon 2 pi. This is 2 product pi. Okay. And then enter. So you can see this is the range from 0 to 2 pi in radian. Okay. From 0 to 2 pi. Now you can choose. Now you can choose any function. I am choosing here y is equal to sine x. Now I want to pass the value x. Okay. And then enter. So these are the values of sine x corresponding to x array. Now you want to plot, you will use plot function x comma y. First will be the input value and the second will be the function. Okay. The y function depends upon x. So independent value will be first, then we have the dependent function. And then enter. So you can see here, we have a very beautiful graph corresponding to the function. This is the graph. Okay, you can maximize it. Cancel. Again, CLC. Now we will do all these things in script file. Okay, and as you know, you can create the script file and you can save the script file in your directory. First, you need to assign the current directory. Okay, but today I am using this directory 2D and 3D plotting. Okay, so all the files, this is a current folder which is available on my desktop. You can see this is just 1 minute. This is the desktop, and on the desktop you can see 2D. Sorry, just 1 minute. Yes, this is my desktop, and on my desktop I have this folder. Okay, and this folder is now I want to assign my current folder, okay, or current directory. So as you know, we discussed as yesterday, you can do in a very easy way. Just you need to go to on this desktop, then go to this PC, then desktop, and on the desktop at the top I have the current folder which I want to assign as current directory. Okay, so that all the files which I create during this session will be saved automatically in this folder. Okay, now here are 2D1 and 2D2. See, I have already created one file. Double click on it. Yes. So here, this is the another way. This is the another way for the range. We are using in this file line space. I have created some files so that I can save the time and the maximum content can be covered during this session. Okay, so you can easily, all these files will be shared with you and will be uploaded on the platform, and someone who are not exist on the platform, then I will create a folder and the folder will be shared on WhatsApp group also so that you can do some experiment, you can use all these files. Okay, so here this is the another way. For the interval or for the line space, you can use as we use in the command window, like x is equal to minus 2 pi, then you can have 5.2, depends upon you, 5.100. You can fix the length of subinterval, then 2 pi. Okay, so this is the way which we are using. Also, this is the another way. Okay, so this is the length of the interval minus 2 pi to 2 pi, and this value 100, this will generate 100 point in the interval from minus 2 pi to 2 pi. Okay, so you can increase or decrease the number of points or the partitions, number of point partitions for the interval minus 2 pi to 2 pi, depends upon your choice. Okay, then we need to define a function. As you know, we choose y equal to sin x function, and then we have the plot function. Okay, and along with we can use some more functions. You can see here, these are x label, then we have y label, then we have title, and you can insert grid on. Okay, may I know from you what do you mean by grid? What are the grids? Anyone? Can you explain by about what is grid? Anyone, please? This statement is okay, no problem. I know this is also okay for all of you, no problem. This is also okay, no problem. And
Can
to
I
use,
can I can I say
yes, yes,
something?
Yeah.
Okay, the grids are the coordinates upon which the graph it will be plotted on.
Like,
Hello, you were
yes,
asking about and what do you mean by grid on?
yeah,
So by grid on, the grid point, that is the various coordinates the
okay,
will be displayed on the graph.
okay, okay.
I
We
don't know if
see.
I'm right.
Yes. We will see here in the graph. So first, what we are doing? All these statement can be easily executed on the MATLAB. You can copy it from this place and you can use them in the command window. You can use in the command window. Okay, so there is no difference. Just to save the time, I'm using here. You can see this is the graph, and whether then you will use here CLC. Okay, and also yesterday I told you that you must start your code with CLC. What do you mean by CLC and clear? Why we are using CLC and clear? Anyone please? What are the use of CLC? What is the use of clear?
CLC means we should clear the command window, while clear means we want to clear the both the workspace and then the directory, so that the values, we cannot have a misinterpretation of values, misrepresentation of values during plotting.
Great. So we are using before starting the script file on the very top, always use CLC and clear if the file is not used for any function. Okay. Here we need only numerical values or the graphical values. That's why we are using here CLC and clear. When you will execute, we have the same graph. Okay. And in this graph, you will observe that on the left hand side, we have y-axis, and at the bottom, you can see that there is x-axis. On the top, we have 2D plot of sine function. Okay, title is there, x label is there, y label is there. These labels appeared by using these three statements. This is the x label we assign here, x-axis. On the y label, y-axis we assign here y-axis, and the title we have 2D plot of sin x. Now we are inserting here one more statement, which is grid on. When you will insert grid on, the grids will appear in the graph. You can see. Now these are the grids. See the difference between the previous image and the current image. Okay, there are several partitions in the form of rectangular or square. Okay, according to the depends upon the width of a sub interval on the x-axis, and then the corresponding values of y on y-axis. Okay, and here when you will do in this form, and length and width are approximately same. Okay, you can see now. So these grids are just horizontal and vertical lines which divide the entire region. Okay, so now the thing is, when you have the graph, how you can save, and because sometimes we need JPG, sometimes we need JPG, then we have PNG, we have a PDF file, we have some type of dot EPS format. Someone who are using LaTeX, and the size of the other format will be very small. Okay, we are not able to use this type of file, because this is the graph which you are observing here is in .m file in MATLAB format, which is FIG. Okay, when you will save this file, this will be in FIG format. But we are not able to use FIG format in any document. So to use these outputs in our Word document or LaTeX document or anywhere, we need the files in JPG or NPG or PDF file, sometimes EPS. So we first we will check which formats are available. Just you need to press Control and S. This window will open, and first you will assign the name. This is figure 1. I am entering here figure 1. Okay. See, when you will click on save or enter, this the format will be f.fig. This file will open only in MATLAB, and you can not use anywhere. But you want to use the file, the image in MS Word file or LaTeX or anywhere. So that's why you need to change this format. When you will click here, these formats are available. You can save this format, APS. I am using this format in LaTeX document. Okay. So all these formats you can see, mostly we are using either JPG and we are using PNG format. Sometimes someone can use this .pdf format also. Okay. And TIFF is also there. This format is also available. So these are the possible formats in which we can save the document for our work. Okay. So how you can do? Either you will select change the format. If you want to return the file in JPG, select this one, and now save it. The file is saved in JPG format. If you want to check, you can go to your folder. This is our folder, and sorry, current folder, desktop. Then go to 2D 3D, then 2D plotting. This is the figure 1 which we create just now, and the file is available at this place. When you will double click on it, this is JPG format, and you can use anywhere this file. Okay. So the thing is, I want to close. You can again use Control S. Control S. Okay. It is not saving. You can go this place and then save as. Save as. Okay. You can enter here dot. This is figure 2. You can write directly here dot .jpg and then enter. So if you want to save the file, in other format like PDF, write here PDF. Okay, and enter. You can save the file in other extension like .eps, but we are not able to open this file in this format. Go to your current folder. Yes, here you can find this is figure 1, this is figure 2, this is also figure 2 in PDF format. Double click on it and you can open. This is PDF file. You can open the PDF file, right click on it and open with Adobe Reader. there is some error. Okay. I think in my system or in this file, there might be some error. Okay, not spotting. Might be while saving there is some error. Okay, so in this way you can save all the files in any format. This is one thing. Cross this file and come to here. Okay, so all the sequence of statement you can easily create here and you can plot them. Now sometimes if you have multiple function, you want to plot two function and you want to compare them, then what you will do? You will enter here one more function, y is equal to, I am choosing here cosine function. I am choosing here cosine function. But now these are two functions. So I have to change the name. First is y1 and second is y2. Okay. And the input value for both functions are same. And I want to plot these two functions in the same graph. What I will do? I will change here y1 and then x, then y2. Okay. Now we have two functions and both will be plotted. You can run from this place. Now you can see there are two graphs. One is for sine and one for cosine. Okay, and both are appeared in the same graph. Now the thing is you can use legend. You can use legend. Okay. So here the first legend is y1, which is a sine function. Okay, you can assign like y is equal to sine x, or simply sine x you can use. Use simply sine function. And then comma, then second function we have is cosine. Okay, rebuild the file. You can see now these are the legend on the right hand side. You can see this is legend. So the blue graph represent for sine function and red line, red curve representing the cosine function. Okay, so legends we can insert in our graph to recognize which function representing the corresponding graph. Okay, so this is all about the 2D graph, and now depends upon your functions. You can choose according to your choice. Okay, now if you want to modify, you can take at this place exponential function. This is we have exponential function, and here is cosine product sine function. Okay, you can choose according to your choice and you can plot them, you can analyze them, you can compare multiple graphs, their behavior, how the two functions or three functions and more than three functions. So as soon as you have two or three, you will increase the statement at this place. Okay, so first pair is for first function, the second pair is for second function, and so on. If you have one more function, you will use at this place comma and insert the next pair. So in this way, you can increase number of functions and all these will be plotted in the same graph. Okay, see now. So here you will see that there is an error. and the error must be there. So you need not worried about why this is array. Sorry, you need not worry about this error because this error occurred due to array. You know, we have two functions at this place. We have two functions. This is one array and this is another array. And here is the problem. We must use dot product. Okay, element wise multiplication as we discussed yesterday. So now when you will use at this place dot, the error has been removed. And you can see we have both the graphs. Okay, one is in this direction and other is in this direction. Okay, but the one mistake is there. First function is for exponential. So corresponding to this, we have to change the labels. Label legend. Where is legend? Yes, this is the first legend. Okay. And this is the second one. Now rebuild. So that this will help you to understand the graph. So blue is for exponential function and the red is for cosine product sin x function. Or you can use slash at this place. And then build the file. Okay. We can use for latex also. Okay, there is error while using the latex. Latex syntax are also applicable here. I need to check. Just 1 minute. I am trying if possible. No, sorry. Okay, so this is the graph. Sometimes we need graph, multiple graphs. See here. This is another way. You can see the line space we have is minus 2 pi to 2 pi. Line space is minus 2 pi to 2 pi. And here we have y1, y2, y3, three functions are there. Okay. And then come here. We have subplot. See here. We are using here to create the subplots by using subplot function. What is the meaning of this statement? And also along with we are using marker. And how you can manipulate the line width also. Okay. So here we are using subplot and subplot will create image in images in the form of matrix. So here is what is the meaning of 3 1? There will be 3 rows and 1 column. The set of images will be appeared in 3 rows and 1 column. And the meaning of this number is this is the first image. Similarly, for this one, we have the second image and this will represent the third image. Okay, so there will be 3 images and for 3 functions. Okay, So here in the very first, we are taking at the place y1, y2, y3, three functions are there. First, in the first image, we want to plot y1 function. This is the statement for y1 function. X is the input value, which is the same for all the and then this is the marker. This is the marker. And this is the line width which we assign at its place 2. This will increase the thickness of the curve. And here is title. This is title because the first function is sin x. So this graph will represent for sin x. Then x label and y label, these are same thing as we discussed in the previous graph. Okay. Similarly, we have the second plot. We have the x function and y2. Y2 is the function and x is the interval which we assign from -2 pi to 2 pi. R is used for red, B is used for blue. Here mark is a single dot and here we are using double hyphen and line width is same. The function is second function which is cosine. X label and y label remain same. Then we have the third plot. Okay, this is the third plot and here we are using this is the third function and G is used for green color and hyphen is used for the same. Then we have the third function is tangent. X label and Y label are same and this is the title. Okay. When you will run the file and you can see the corresponding to each three function sine, cosine and tangent, we have three different graphs. Okay. So the command which we use at this place was 3, 1. So 3 rows are there and all these images are in one column. And for the first figure, we have 3, 1, 1. So for comma 1, we have the first image. When you are using comma 2, second image, comma 3, third image. Okay. If we change at this place, we are changing, we make at this place 2 and this is also 2. What is the meaning of this one? The images set will be in 2 by 2 matrix. Images will be in 2 by 2 matrix. See, I am changing this value. You can change from this place also. Sorry. And now this will return image in 2 by 2 order matrix. Okay. But here image 1 is there, image 2 is there, image 3 is there, image 4 not exist. So that part will be empty. See. First image we have, this is the second image, this is the third image, and fourth image empty because we have only three functions. For the fourth place, we have to create one more function. Okay, and you can do easily. Yes, what I will do, just I will take one more function, enter at this place y4. Y4 is equal to, suppose I am taking exp function and x will be passed from this one. Okay, and semicolon, then I will plot at the copy all this content, and paste here. Simple, copy and paste, and all these file which I am presenting here will be provided you. This is the fourth. Okay, and at this place you will enter 4 because this is the fourth image. but the function you need to change, this is fourth function, y4. And if you want to change the color, you can use at its place K. K is used for black color. I will later on, I will provide you the list of the colors which you can use for the MATLAB, which we and also the markers, different markers list. All these I will provide in the PDF file, will be uploaded in the platform, as well as I will provide you in the WhatsApp group. Okay. See now what happened. Yes. We have 2 by 2 order matrix of images. And also if you want to insert grid, you can do grid on. Grid on. Grid on for the first image. Grid on for the second image. Grid on for the third image. Grid on for the fourth image. You got it? All these things are interesting. Are you enjoying my lecture? Are you following me?
Yes, sir.
Sir,
Yes, please.
yes, sir, we are following you, sir.
Pardon?
We are following. We are following you.
Okay, thank you. Thank you. So now if you want to save this file, Control S, and then figure 1 is there, figure 2 is there, give the new name. This is figure 3. Okay. Dot, I need this file in JPG format. Dot JPG. Okay. And enter. You will find that this file automatically goes into your folder. This is my folder. This is the figure number 3. Yes, you can see. Okay, all the graphs are there. Now we will do some more interesting part, more useful, and first I will explain about close this one. Then you will scroll down and you will get more and more information which is available at this place in this file in MATLAB itself. Okay, here are the 3 functions are used, and this is the corresponding example. Okay, if you want to know the colors in MATLAB, there are different patterns are there. You can see here G is used for color, bay color, and this is the blue color with the marker is used. Okay. So by using these markers, we have this graph. You can try all these just by copying from this place and copy this place and put in your MATLAB by creating one new file. I pasted this place, save it. This is 2D3. Okay. This is 2D3. Save this file first and then execute. Whoa, we have the same graph. Okay. If further you want to insert some more information like marker, etc., you can do X label, Y label. We use at this place. Okay. You can insert all these statement. And you can insert the grid also. Just copy and paste what I have done. Sorry. Yes. Okay, you can insert the grid for all the functions. Simple. Just you need to play with MATLAB. MATLAB itself will teach you all the things. Okay. Here are various type of examples are there for different type of graphs in for 2D. This is the complete list of the graph of 2D, which is available here. Okay. Yes, you can find the different type of patterns of the images. Also, in the same file, you can get here some more information. Input arguments, a single point, one set. Okay, all these content will help you to understand the images, to understand the statement, syntax, and how you can use. And also you can get here the markers and line style. Okay, very interesting. So when you will use this single hyphen, there will be this solid line. When you will use double hyphen, this the line, the shape of the curve will be in this pattern, dashed line. When you are using this type of colon, the line will be in dotted line. And when you will use hyphen and dot, then line will be in this format. Okay, so these are the line styles. Then you need to understand about the markers. So these are various type of markers. Examples are there. Small o is used for the circle, plus is used for this sign. This asterisk is used for this sign. All these are the markers which you can insert in your graph to customize the style, the pattern. Okay, so diamond is there, up cap is there, lower cap is there. Okay, and also along with the you can find the short name of the colors which we can use in MATLAB. We use red, we used green, G is for green, B, C, cyan. If you want to use magenta color, then you will use M. Okay, Y, K, Y for yellow, K for black, W for white. Okay, so these are the color patterns, and when you will scroll down, you can get some more information which may be helpful for all of you. Okay, so there here are some more colors are also there. As soon as you will do practice on it, you will customize according to your need, according to your desire. So this is all about 2D plotting. Now we want to discuss about 3D plotting, and along with we must go through the power presentation is also. Okay. So Control F5. Is there any doubt related to the present discussion? If you have, please feel free to put your question. You can unmute your mic. You can put your question in the chat box if you are not able to unmute your mic. The lecture must not be one-sided. If anyone have any question, please feel free to ask from me. PC Thakur, hello sir, good evening, how are you? I'm very happy to see you here. Dr. Nasir Ahmed, Vivek Sharma Sinha, okay. Good evening, respected all, my dear colleagues. R. Kavita, Pardeep, yes. If any question, please feel free to ask from me.
Sir, what is the meaning of SD title we have used in the last week?
Pardon? I don't exactly get you.
Sir, I have put a question in the chat box.
Chat box, okay. Okay, no doubt. You are saying that, no doubt. Okay. Thank you. If there is no doubt, but I am not so perfect that I can explain everything. But if you have any question, please don't shy. Okay, so I'm sharing again my screen. Okay, so yes, this one and the demonstration of variable, this part has been covered. Explanation of representing mathematical expression in MATLAB, use of a symbolic variable and expressions. Benefits of symbolic representation in mathematical plotting. This part will be covered in when we will cover symbolic mathematics. That will be specific lecture, but some content has been included at this place. But we will cover this part in the coming session. I would like to skip here. Z plot, okay. We will cover Z plot and how you can use. Very interesting part. 3D plotting after that. Okay. Yes, so you need to come here and search here EZ plot. Suppose I don't know nothing. So what I will do? I will take help from MATLAB. Okay, why I am saying that? Because as you are beginner and also today myself, I consider that I am beginner and I don't know about MATLAB. So this thing will help you if you don't know nothing and how you can take the help from MATLAB. I choose only EZplot and I want to use this function for plotting. You need to enter and you will see that here. Click on it and here are the examples. Also you can see at this place message, there is a message for the same, and MATLAB is saying that EZplot is not recommended because I think it has been updated now. Okay, and in the place of EZplot we can use fplot. Okay, but it is also give us some examples to use EZplot. See here, we can copy this statement. Okay, this is the syntax. These are the syntax which we can use and come to MATLAB. Close this file. Okay, CLC and clear. Okay, now workspace is clear, command window is clear, and again CLC. Everything is clear. We are using now EZplot. What you will do, you just enter at this place any function. We are entering here sin x. See what happened. I don't know what happened. Just we are doing experiment. It is saying that unrecognized function of variable x. We did not assign at this place x range. So first we have to take the range for x. Okay. So you can choose 0, then colon 0.01, then colon, and at this place you can choose 5. This is my input value. Okay, and semicolon will be used for suppress the statement. Then upward arrow sign and then enter. Input must be character, function name, function, handle line. Okay, I don't know how we can use, but we will take the help from MATLAB. I forget to use how we can use EZplot. Okay, so what I will do, we will scroll down. This is the exact way to use. Okay, I make mistake to use the function. Yes, this is the right way to use the function. See now and enter. Yes, we have the graph of x square. This is the y is equal to x square. This is y is equal to x square, graph of parabola. Okay. Now we can use our, yes, this one. Here was the mistake. I did not use quote sign. This was mistake from me side because now I am learner, not the expert. And enter. You can see just in single statement, we have the corresponding graph. Just you need to insert only one statement. Okay, so AZ plot and F plot have same functions. Similarity. Okay, go to add place, and add place you can get some more examples and how you can customize also. Various examples are there. You can go to the examples also. Okay, here you will find various examples. Okay, these are the live script files which you can use. You can edit in a line, a live mode. Okay, when you will click at space and you will find that this is the entire code in the live mode. You can edit them and you can run the file. You can click at space, open live. When you will click on it, this is the live mode. This is the live mode on the MATLAB, and the content will be available in your MATLAB. Okay, the file is now in live mode in your MATLAB, and these content you can see at space. Okay, you can edit this file. All the things are there. So when your cursor is at its place and go to run this section. So this section has been executed and all the graphs of the statement are there. You can find. Just you need to go to run this section. Okay. So the entire file has been executed and corresponding to each, you can see the graphs in your MATLAB. This is the live mode. Okay. If you have this code, then you will have this graph. Okay. I did not prepare any code. I don't know which type should I don't remember nothing. Okay, just I am taking help from the MATLAB itself. For the today's session, I did not prepare nothing because if you are beginner and today I also beginner, but the difference is that I know how I can use MATLAB, and in the same way how you can use the MATLAB for yourself. Okay, all the things which you need for the beginning is available in the MATLAB. Okay, now close this one. And CLC. Now we are talking about 3D plotting. I have prepared the script file and only I think 10 minutes or more. Maybe I will take 15 minutes and within this during time, I will present 3D plotting and how you can use. The script files are ready and within 10 minutes, I will be able to present all the entire script file, and I know all these will help you. But the thing is, when you are thinking to plot 3D, this is very quite simple because the basic concept for 2D will be helpful for 3D also. Just the difference only is that when we plot 2D, we have one independent variable and the second will be dependent. When we are thinking or plot for 3D, in that case, two variable will be independent and one will be dependent. Okay, so this is the only minor difference, and rest all the things are very simple and very simple to implement, and a new thing will be there. like box and grid will be used. Okay, see in the MATLAB. Just 1 minute. This is live, and I have to open my current folder. Just 1 minute. This is desktop, and this is my current directory. Okay, and in this current directory, I have several folders. Yes, this is virtual 3D workshop, and I prepared some 3D plotting. Yes, all these files I will provide you so that this will help you in many ways. Yes, see, very interesting. Here, CLC and clear, these are the description about the plot which are commented. Just to understand, we are using here, there are several functions like plot 3, mesh is there, surf is there, contour is there, surf C, EZ plot. All these are different functions to plot 3D plotting. Okay, and you can easily use, you can get help from the MATLAB also. Okay, just here I prepare some script file. So these are the sequence of statement. Only these statement which I highlighted at the place are required. CLC and clear, you are very familiar, and T is a parameter. T is parameter. Okay, so the parameter is from 0 to pi, and plot 3 we are using here to plot the graph. So here sin t, cos t, and t, these are the three equations in parametric form. One is Z1, then Z2, and Z3. These are three equations in parametric form. And by using these three parametric equation, we can easily plot. Okay, see here. So these are the like a grid on, box on, axis square, X label, Y label, Z label, because here are three dimensions. So we are using three label, X label, Y label, same as which we use for 2D, and here are three dimensions. So third dimension will be there. Z label used for Z axis, and then we have title for 3D plotting. Okay, box on and grid on, you know very well. Box is also required. If I will remove, comment this statement, see the graph. Okay, this is like a spiral, and on the X level we have x-axis, on the Y level we have y-axis, and on the Z level you have z-axis. Okay, and the curve was in parametric form, and that's why this is the graph in 3D corresponding to the input values. And also from this place you can see here are some icons are there. When you will click this rotate, you can rotate this diagram in any direction. Okay, this is rotatable at 360 degree in any direction you can do. Okay, so yes, I close this one. If you will use this statement also and box on, now you will see the difference between the previous and this diagram. Yes, now when you will use box on, it is more like appealing diagram. Okay, so now you can easily observe the dimensions, and box is there. Okay, and by using the same icon, you can easily rotate this diagram in any direction. Okay, 360-degree angle. Okay, you can rotate. Doesn't matter how many times you are rotating. Okay. Yes. you can rotate in any direction. And after that, you can fix, you can save the file. By saving the file, Control S, and this is plot 1.jpg. .jpg file has been saved in my current directory. Okay, so and then you need to click on the next file. Here you can see that 3D line plotting. We can use mesh grid. Okay, when we are thinking to plot 3D, and we have the function which is depending upon x variable and y variable. So the dimension number of points along x and y must be equal. Only then we can plot this diagram. Otherwise, we are not able to plot. Okay, so mesh grid, what will do? This will convert x array and y array with the same number of point. Okay, and this is the z. Z is a function which is x into exponential minus x square minus y square. Don't forget to use at its place dot, because this function contains various arrays. Like x itself is one array, exponential function is one array, both are multiplied. So this will be pointwise multiplication. Use dot. Again, x square is x is one array, and x square means x product with x. So use dot at its place also. And similarly, we have y square. This is also the product of y with y. So that's why we are using at its place dot also. And we are using to plot the same plot 3 function. When these are the similar statement for the grid, for box, for x label, y label, z label, you can insert the title also. Okay, when you will execute the statement by pressing this upward arrow sign, and you can see we have this graph in 3 dimension. Okay, so you can see, you can rotate in any direction, depends upon your choice. You can see. And after fixing the position, if you want to save this image, just you need to fix the position which visualization is more appealing for you. Fix the position, then use Control S, and this is the plot 2, and .jpg. Enter. The file has been saved in my current folder. You can, if you want to check, you can do. Yes. This is the plot 2D. Yes, this is the image plot 1. This is plot 2. This is the figure 1, and this is the figure 2. Okay, so as you will fix the position, you can plot them. So here you can see that we have x dimension, which is different. X and y both are not same. X is from 0 to 12 and y is from 0 to 8. Okay, and when you will generate mesh grid, see, at its place, the dimension of x and y are equal. Dimension of x and y both are equal. So this is very important. Otherwise, if the dimension will not be equal, then you cannot plot 3D. So the plotting will possible only if you have dimension of X and Y must match. Only then the 3D plotting will possible. So this is the one example. And if you want to click at this place, you can check the corresponding values. So here the interval is from 0 to 12. Okay, but we have the size is 5 by 13. 5 rows and 13 column. Okay, similarly you can check the Y and see the difference between here is also the values are 0 to on the horizontal line we have 13 points are there, and on the vertical you can see 5 points are there. The size of this matrix is also 5 by 13, and here is also this one, but in this case the values are increasing in this direction, but the second one the values are increasing in this direction. Okay, but just it generate it make the equal size of the inputs for 3D. So this is the use of mesh grid, and to equalize the dimensions of X input and Y input. Okay, so here you can check some more examples here. This part I comment here so that you can uncomment all this, and details corresponding is available here. Just you need to uncomment all this and execute the file. Okay, so here I have this part. X is there, Y is there, then we have the mesh grid, then we have the function, same function is there, but we are using here some different function. We are using here mesh. Okay, see. Yes. So this is mesh. Okay. This is mesh. You can see. Mesh means this one. This is mesh. Okay. Now it is in 3D. And if you use at this place surf, SURF, surf. Surf means surface. So now the empty space has been covered. Okay. So this is the surface of the function. Also, you can observe from this place, grids are there. Okay. Mesh is there along with the empty space has been covered with color. And there is some sense of this dark blue and yellow. Okay. The yellow part will be on the top and the dark blue will be in the depth. See. Yes. Okay. Yellow part will be on the top and dark blue means in the depth. Okay. And this type of images, when we get from the space, help us to study the ground. Okay. When we get the images from the space, we get in this form. But the yellow part and the dark blue part tell us some information. That's why it is very important to understand the visualization. What is the purpose of visualize of any image? And the persons who are working in image processing can understand better than me. And they can explain in more detail. Okay. Next, I will provide all these content which I am presenting here. You can use here mesh grid and ZS function. Surface function is used at the place. Color bar, you can use color bar. So when you will use this color bar, see what happened. Yes, we have this, and on the right hand side, you can see the color bar, and there is used also the color, this color bar to study the behavior of this image which you get at this place. Okay, so this is some type of diagram. I don't know depends upon the equations which we.
Please, I have a question.
Yes, please. Yes, please.
Yes, how do you want to interpret that color bar?
Yeah, color bar. You can see, as I explained, the most yellow color means the highest point, and most dark blue means the lowest point. Okay, here you can see the scaling. 1.5. Okay, this is the top yellow, and then you can see at the bottom minus 0.1.5. Okay, so you can see on the left hand side, we have the image, this surface lies between -2 to 2. Okay, so it tells us that the graph will range from -1.5 to 1.5. Okay, this graph will not touch the plane. This graph, this surface will not touch the upper surface. This will lies between -1.5 to 1.5. Okay, so the colors which are appealing in this image are ranged from -1.5 to 1.5, which you can see in the bar graph. Okay, color bar graph. Okay, so this will help us to understand the image and which point is more appealing for us. You can see when you will do in this way. See, now the image is we are observing parallel to the horizontal plane, and you will see that the maximum value is nearly 1.5. Okay, and on the right hand side you can see the end point, which is again we have -1.5. So from this position we can easily observe -2 is the bottom point and 2 is the top point of the box. So this image will this graph, this surface which lies inside the 3D box, okay, never touch the upper surface, never touch the lower surface. Okay, so this range which is appealing in this image will represent the color bar and corresponding to the values.
Thank you, sir.
Got it?
Yes, sir. Thank you.
Yeah. And when you will do scroll down, and scroll down, you can see there is a small box inside in the center which is empty.
Yes.
There is one. Okay, so very interesting. You can move in any direction. You can analyze all the part of this image, how the function is behave. Okay, corresponding to each value.
So why is that? Why do we have the empty box?
Pardon? Oh, why is this empty? I don't know, because the depends upon the function.
Okay.
Okay, I think the values at this part does not exist, or we are not getting the value at this point. So you can see this is about this line at 0 and 0 point something on x-axis and on y-axis. The value of the function does not exist. We don't have the value. That's why we don't have the surface. That's why it is empty.
Okay, maybe it corresponds to the point of zero interaction. That is why.
Yes. Yeah. Okay.
Okay. Thank you.
Interesting. And again, if you want to save, Control S and give the name plot 3 and enter. Just I will take a 3 to 5 minute more. Please don't leave. Some of the participants are waiting to end the session. Yes, I will do also end within 5 minutes. Double click on it. Yes, also in the same way as we do for the previous subgraphs, you can plot here also subgraph. You can see subplot function is there, subplot is there. Okay. In the same way as we do in the previous for 2D, you can do the same pattern in 3D. Many things will be similar. You can see here. Also come at this place. In this box, there are some more files which I am not able to present. You can easily use them. This file is okay. This file is also okay. Yes. Okay. So come the first one. Here, this file has been discussed already. Okay. You can use surf function. You can use surf C. You can use at this place C also. Then C means contour. So surface as well as contour both will appear in the same graph. C. See in the same, this is the same graph, same function, but you can see the surface is there and along with the contours are there in the plane. You can see at the bottom, these are the contours. You can see the contours of the surface in the same image. So when you will use the surface with the C, this will the two graphs will be there, surface as well as their contour. Sometimes you need to combine two images. Then you will use hold on and hold off function. Okay. Here you can see we have X and Y. Same thing. Mesh grid will generate. This is the first function. Z minus X square minus Y square. And the surface function will plot the graph. Okay. This is one graph. Okay. If you want to combine one more graph in the same image, just like sometimes we need intersection of two bodies, like one is a sphere, one is a cone, one is a sphere, other is a cylinder. Okay, we studied various type of problems while integrating 2D or 3D, but we never plot them, but not easy to plot. Okay, the engineers who are studying some civil type of problems, they know the intersection of the two bodies, how these will appeal, what will be the common surface, what will be the common area, what will be the common volume, etc. So in that case, we need to combine two images. So here we will use hold on function, hold on and hold off. So here Z is one function and this is the another function. Okay, we have two functions and the surface is used at the place. So hold on and hold off. Between these two, we will insert the other functions which we want to merge with the previous one. Okay, then these are the same pattern we are using. Box on, X label, Y label, Z label, legend. Legend is also used at the place because here are two functions. That's why we are using legend for 3D also. Check it and you can see that we have two surfaces. One is on the top and other is at the bottom, and Z is the first function. This color, yellow color, is appealing for Z function and blue is appealing for the W function, the second function. Okay, and both the surface you can see are inserted in the same graph, and we can you can easily compare the images. Okay, by rotating you can analyze them, you can study easily the behavior of these two functions. Both are combined in the same image. Got it? Got it? Okay, this is the same example, but the thing is that this is the difference. See the difference. Here, this is the X interval and this is the Y interval. Both are different, but the mesh grid is used at the place. Okay, so this will make equal dimensions for X and Y both. And you can use mesh function. You can use other functions like plot 3. You can use surface function, surface function. Okay, many things are there. You can see now. This is the graph. Okay, you can rotate in any direction. You can use box on. Grids are there. Okay. And here you can see we have the same function, but we are using subplot in single statement. And very interesting, you can see that we have 4 different type of graphs in the matrix form. Okay, so here 2 to 1, 2 to 2, 2 to 3, 2 to 4. So there are 4 images. In the first we are using surface, in the second we are using mesh, in the third we are plotting contour, in the last one we have the surface and contour, axis, square, box on, each. These are same statement. Okay, only this is different. So when you will execute, see what happened. Yeah, very beautiful diagram is there. So this is the surface mesh. In the third last one we have surface as well as contour is there. And in the third image we have only contours, you can see. Got it? And all the images are appeared in matrix form. As we do for 2D, in the same pattern you can do for 3D. If you want to change this one, you can rotate this also. You can see. Just you need to select this rotate 3D icon and go to the image, left click, and you can rotate in any direction. Similarly, you can do this one. You can rotate. Similarly, you can do for this one, but you cannot do this one. You cannot rotate because this is 2D. Okay. So this is all about 2D and 3D. Last is there is also see the difference. Okay, this is the same example which we use for the parametric form. Okay, so you can also is z plot you can use for the parametric functions. You can see here. Here we have is the statement. This is the first function, second function. This is the third function. Then we have, okay, this is the one function. And this is the second function. This is the third function. And this is the range 0 to pi for t parameter. Okay. So you can uncomment the statement. You can comment all these. First, you can observe these 3 equations. Okay, this is the first function, first equation, second equation, 3 equation. All these are in parametric, and you can use EZ plot. EZ plot will directly return the graph. See what happened? Yes. Okay, this is the corresponding graph of the 3 equations. And you can use the other ways which are explained at this place. Just you need to comment all these statement by using Control and R, and you can uncomment this statement by using Control and U. Sorry, why? No, Control T. Control R is used for the comment, and Control T is used for uncomment. Okay, so now this statement will execute. See, we have this graph. Okay, and again you can comment this statement and you can uncomment this statement. Control T. Yes, check all this. Yes. Okay, so this is a curve in 3D. You can see. Okay, so various examples are there. So this is all about 2D and 3D, which will help you in many ways to visualize your findings, your results when you will study about different type of models based on ODE, ordinary differential equations. There are various type of models which are based on partial differential equations. There are numerous models which are based on system of differential equations and system of sorry uh, linear equations. Okay, so there are so many problems and when we get some of the result, we need to visualize them to study our findings. So the content which I present here for 2D and 3D plotting, whether the data you have is in the form of Excel, you can use for the plotting also. And I hope the content which I present here are very useful to all of you. Now the session is open for discussion. First of all, I should thank you to listen me very carefully, patiently, because to listen anyone is very hard. And I feel proud of you that you are listening very carefully and you are taking interest in my lecture. Now the session is open for discussion. If you have any kind of question, please feel free to ask from me.
No question.
I am not happy. You listen me 2 hours and you don't have any question. I will be very happy if you will ask some questions.
Good evening, sir.
Very good evening, beta.
So, what is the difference between plot and EZ plot?
Okay, but these are the functions in which are inbuilt in MATLAB to visualize the inputs. Okay, like surface, surface C, all these are different type of functions. By using these functions in the MATLAB to visualize, because if you want to plot, then uh, you need some function. Okay, you need to pass the values because MATLAB is compute based instructions. We need to instruct the MATLAB, and MATLAB will understand only the functions which are available in MATLAB. Otherwise, we have to create the functions to make our input statements for the MATLAB, because when we give the input, only then it will return. So these are the instructions which type of output we required, and as our desire, according to that we have to give the instruction to the MATLAB. But before using the MATLAB, we should be very familiar with MATLAB, which type of functions are available in the MATLAB, and what are the purpose of these functions, how we can use, how we can manipulate for our different type of findings. And if just 1 minute, once again, I am going to share my screen and see here. One point I skip to present here. Yes, yes, just 1 minute. Yeah. So line plot, vector plot. Yes, here you will get all type of functions are there. 2D and 3D. When you will get line plot, when you will get surface and volume. See here, surface volume. Yes. When you will click here, surface and mesh plot, you will get several functions are there. Surf is there, then we have surface C. Okay, then we have a surface function, surf1, surf norm. Okay, and corresponding to all these function, you will get various type of examples are there, and each function has some their property. Okay, see here, if you want to, I give you one example from the MATLAB itself. Surf norm. When you will click at space, it will give us the syntax for the same. And also the MATLAB will tell us the example. Yes, you can see. Here is the example, and for the cylinder, this is the surface, and along with the norm. What do you mean by norm? If you are a student of MSc, you know very well about the norm, and you can see the norms on the surface of this cone. Okay, so according to the visualization of the result and based on those, the functions are developed, and you can see surf norm, surface plus norm of the surface. Combining these two, we have a function which is available in the MATLAB, means surf norm. So this is the surf norm function which will generate the surface as well as norm to the surface, and you can see. Similarly, you can see here one more example. Okay.
Yes, sir.
So there are various type of examples in MATLAB and will help you. You can see, you can go to the contours. Okay, these are the different type of contour. Okay, you can check one of them. Contour f function. I am checking this contour f function, and you can check here. These are the syntax. Okay, these are the syntax which we can use for how we can use this syntax. Now you need to understand how you can give the input. For that purpose, you need to check the example. Okay, example is here. This is some type of function peaks, and we need the contour for this function. Okay, this is inbuilt function in the MATLAB, but you can create your own. Okay, and contour f will return the image you can see in this way. Here is also one more example. This is x. Then we have y. Mesh grid is there. Okay, this is the z function. Okay, you can take from this place, copy and paste. You can manipulate according to your desire. You can use your own function. Close all these. MATLAB is very interesting for all the peoples, but you must be very familiar. You need to train all the things. You can see this is a very beautiful graph. Okay, you can change this function. You can have different type of function, but you need to understand the behavior. What is the purpose of contour? First, you need to define what is the contour and why we are studying contour. Okay, then the visualization will help you for more understanding. Okay, we in the class we study only the theoretical part, but we never study their behavior. We never try to understand the visualization type, what is the meaning of the contour, how they will behave. Okay, so the visualization part will help us in many things. Got it? So all these are inbuilt function in the MATLAB which we can use directly. Any more question, please?
Thank you, sir.
Any more question? I think there is no more question. First of all, I am very thankful to all of you to listen to me very carefully, and all the content which we present during this session, the recording it will be available today for the today's session, and the recording for the yesterday's session I will upload after this session, and I will provide you the link in the WhatsApp group also. The content which I present here will be uploaded in your account. You can log in your account who are registered on the platform. Okay, as well as I will provide all the content in the WhatsApp group so that the session will be more informative, more helpful to all the participants who are taking interest in this lecture. So thank you very much to listen to me very carefully, and tomorrow at the same time we will execute the session, and I will wait for all of you very eagerly sharply at 7 p.m. Link will be available 5 minutes before 7 p.m. Thank you very much to listen to me carefully once again, and hopefully all of you will be available to listen to me again. And tomorrow the session will be more interesting, and the content which we present yesterday and today will be useful in the coming sessions. Thank you very much.
Thank you, sir.